Did you know that being at the equator is weird? Because this guy shows us some crazy physics that happen here. I'm currently in Kenya, one of the only 13 countries in the world where the equator passes through, an imaginary line that divides the world into sides. This line passes through 4 different towns in Kenya, and as we were taking a ride towards north, we saw this sign at 6,389 feet, where the GPS is 00 degrees. And here, this man shows us some crazy physics that makes me want to go back to school.
So this is exactly the equator. You know, equator is an imaginary line which goes all the way from east to west. So equator divides the world into 2 equal hemispheres. So this is the northern hemisphere, this side is the southern hemisphere. So we have a demonstration here on how water is affected by the line of the equator when we move to the north, when we move to the south, and when we come exactly on the line.
On one side, water will spin on the right side, and you take steps over the line to the other side, water spins to the left. What? And the craziest of all, standing right in the middle, there is no movement at all. And they call this the Coriolis effect. For as crazy as this was, I had to ask you a question. What do you think? Is this equator effect a real thing? And how is this possible? Let me know on the comments below.
So when I pour water on the ball, let the water drain through the small hole here, you find that it rotates clockwise in the north like a clock. When we close the line, we move to the other side of the equator, southern hemisphere, it rotates anti-clockwise. And to prove that we are right on the line, when we come exactly on the equator, no rotation, the water stops and drains straight down. So to see these changes, we have to move some few meters away from the equator, that is 20 meters both sides, then we finish on the line. So 20 meters is the minimum distance whereby we can see the effect. So let's start from the north, 20 meters, whereby the water rotates clockwise. So now we are moving to the northern hemisphere, 20 meters. And this is the point. Here it marks 20 meters north, whereby the water rotates clockwise. And because with clear water you can't see it clearly, these are the sticks here which act as indicators to show how the water rotates. So whenever you move in the north, always the water rotates clockwise. So this force or the effect is called Coriolis force. So Coriolis is the person who discovered the force. That's why it was named after him, Coriolis force. So you find the same thing happens when you flush toilets and when you open watering taps, depending on the sites they are located. And note this, the far we move away from the equator, away from 0 degrees of the equator line, the faster the water rotates. The nearer we move toward the line, the slower the water goes. When we lift the ball, look at the bottom here, you can see as the water goes, it has a spiral spinning this way. These are the spirals spiraling as the water goes clockwise. So when you go to the south, you find that the spiral spins the other way. So even if you try to make the indicator rotate the other way and clockwise, it can't because we are in the northern hemisphere. So this is what happens in the north, clockwise. So when we get to the southern hemisphere, the water changes to the other way, counterclockwise. Okay? So now we are going to the other side of the equator, southern hemisphere, and see what happens. Let's move to the south. Moving to the southern hemisphere, 20 meters, whereby the water rotates the other way, and clockwise. And this is the point, 20 meters south, whereby rotation goes anti-clockwise. And I use the same ball and the same stick. These are also the indicators which shows how the water goes. So you can see now the water is turning the other way and clockwise. So this is how we differentiate between that half and this half, the northern hemisphere and southern hemisphere. When you look at the bottom also, see also the spirals spiraling the other way. But when we get exactly on the line, because no force which can control the water to rotate either way, you will find that no spirals, just the water spins very straight. So what happens on the line, as I told you, you know the near we move toward the equator in both sides, the slower the water rotates. And for that reason, because the force is getting weak as we move toward the equator, when the two forces meet on the line, they balance it. So equator is a neutral point. No force which can control the water to rotate either way, but the water spins very straight. Now we are going to the equator and see what happens. Let's see what happens on the line now. All right, so now we are moving to the equator. 0 point. This is a 0 degrees, whereby no rotation. So what happens here, you find that unless the disturbances of wind which controls the indicator. Here no uniform rotation as you have seen in north and south. So here the water spins very straight. And as I told you, this is how we prove that we are exactly at the equator. Let's see. Look at that. No rotation. Yeah. Even if you try to force the indicator rotate either clockwise, the way it was rotating in the north, it can't. Make it rotate the other way, it can't. But when you look at the bottom here, you can see the water is going very straight, no spirals. So this is how we prove that we are exactly at the center of the world, Coriolis force. Unless you have any question, that's what happens along the equator.